right, here in Unit 6, we are in 6.11, which is the very last topic for this unit, which is parallelograms. So yay, we're almost done with our proofs unit. Also, yay, parallelograms. So the definition of a parallelogram is a quadrilateral with opposite sides parallel. And the interior sum of a parallelogram is always 360 degrees. And this is true of every quadrilateral. They have an interior sum of 360 degrees. So we're going to do a proof. We're given that the quadrilateral quad is a parallelogram. We're going to try and prove that opposite sides are congruent. So we're going to prove that QA is congruent to AD. So we're going to start with QUAD is a parallelogram. And I'm just going to draw a cute little parallelogram for the word parallelogram. And this is just given to us. My favorite parts of proofs, that given part. All right, so I know if it's a quadrilateral, that means that QU is going to be parallel to DA, and DQ is going to be parallel to AU. In other words, opposite sides will be parallel. So this will be parallel to this, and this will be parallel to this. Now I've marked it on my shape. That's helpful for me. And this is just by the definition of a parallelogram. What a cute little parallelogram. All right. So now I know if those lines are parallel and they're cut by a transversal, look at this cute little transversal they got going there, then alternate interior angles are congruent. So I know that angle 2 is going to be congruent to angle 4 by alternate interior angles, as well as angle 1 is going to be congruent to angle 3. Well, right now I have an angle thing going. So let's see if we can get one side, because if we can get one side congruent, then we can get everything else congruent, right? Because it would be angle side or angle side angle. Well, if we look at that line that's connecting Q and A, that would be shared between two triangles there. So if I can say that QA is congruent to QA, which is the reflexive property, then I can say that triangle DQA is going to be congruent to triangle UAQ by angle side angle, because it's this angle, this side, and this angle that are congruent. So if they are congruent, now using CPCTC, or corresponding parts of congruent triangles are congruent, we can say that D or QU, so I'm going to draw my line so that it doesn't get mixed up with my other stuff. So I can say that QU is congruent to AD, and I can say that DQ is congruent to UA. Fantastic. Look at us go. We're killing it. I want you guys to go ahead and give this proof a try. So you want to prove that opposite angles are congruent. So you want to be able to prove that Q is congruent to A and D is congruent to U. My hint to you is you're going to be using that congruent triangle thing again, but you're also going to have to use the angle sum postulate. So, the angle addition postulate. So you got this. And we will meet back together here